under the vacuum conditions. Next, about the software overview. When you touch the LCD display, first it will be look like that, and here we are going to discuss about all each and every point about the LCD control. About the first line here, the first on the top of the screen, it will be show what is the pump status, how much pump we already did inside the closed chamber. Next, about this is called the auto process. There are two kind of process. Either it's called the auto process, and the second is called the manual process. In here, this line it will be show the auto process and the manual process. Next, about the auto vent. Auto vent generally required. Suppose you want to take out your substrate, then we have to apply the external air supply, so that the vacuum it will be maintained as our atmospheric pressures, and this auto vent is start activated. Next, about this is called the auto pump condition. Auto pump condition, we can able to access our pump which we are using by the help of the software. Next, about this is called the abort system. Suppose you want to go from automatic process to manual process and manual to automatic. That time we require to select this abort process.
So this is an interactive screen. You can touch it and
exactly, yes. No, we can touch and you can make the changes. We'll discuss in the next slide.
What is the difference between auto and manual process?
Sorry?
What is the difference between automatic and manual process?
Yeah, automatic process we are going to use the controller, and the manual process we can hit your your material, and we can receive all the substrate. But for the measurement of the thickness, we have to use the other equipment for characterizations. For the manual, we can deposit your material, but we cannot monitor.
But the balance, of course, all the time is there.
This thermometer is there.
Yeah.
But will not be measuring frequency.
So the difference is for the measurement of thickness.
Yes, the measurement in the techniques, yes. But sometimes this manual process is very helpful, because suppose I am using the unknown kind of filament. Directly if I am going for the auto process, we are applying the higher pressure, so that it will be big. But in the manual process, we can apply the 10%, 15%. We can understand what is the sustainable power. That is sometimes manual is the helpful, because this is called the heat and trial method. Because in the evaporation condition, we cannot say 100% that suppose I am applying the 10%, your process it will be complete. That time we have to apply some power, and you have to observe, monitor your process. They are how they are getting activated inside. That we need to monitor. Is okay? And here, the one more touch point here. Either by help of this two touch screen, we can take the bale jar either up, or we can take it down. Okay. If you touch this screen, then another display will be open. This is called the overview screen. When you first turn it on the system, the first display will become. But when we touch this screen, the other window it will become. In the next slide, we are going to discuss about the second screen, which I brought in the last slide. First, about the process. Here, if you touch this process, then we can see what is the starting process and what is the pressure we need to maintain here. Second, about this is called the low voltage evaporation system. We are going to use the low voltage evaporation systems. This is called also the DC This is called also the DC evaporation conditions. We are going to use this technique, this low voltage technique in our process. Overview, if you touch this overview as a display, then it will be returned back to the main display. Next, about this PLC and the service touch screen. It's recommended to not play with this tab, because if you playing this tab, then this PLC will be, and the service tab, if the any interlock, input it will be changed, then it will be take longer time to repair, because we have to check what was the correct input sensor they are using for controlling the process. This is the only for the service and maintenance purpose. That's why I put the red color, especially for these two tabs. Next, about the pump control options. If you touch this one, they will only access about the pump condition, like what is the pump, how, which one you want to turn it on, what you want to do. You can access about the pump condition also. One. Next, about the rotations. If you are discussing about the substrate rotations, we know this is a very important parameter to rotate our substrate. Next, about the gas supply line. From the gas supply line, we can apply the external gas. For the doing the sputtering, the people they are using the argon gas in different lab, because argon gas is the very compatible for the doing the sputtering process and doing the coating of the thin film. Okay. Now just in the one screen I put the all display to just look how the, if you are touching the all display, how it will look like that. I just put the all display. This is the screen selections, and after that if you touch, for example, just I'm explaining one by one. If you putting this pump control, then it will be show this display, like it will be rough pump, turbo pump, vent valve, which you want to on. From here manually you can control your vacuum, you can applying the air pump by help of this pump. Next, about if you touch this rotations display, then this point it will become the power and set point. The second,
the set point is percentage. You said from 0 to 20 RPM. So percentage of the 20? Percentage of the power percentage. Generally we are going for the 50%. 50% power which they are going to rotate by the 10 RPM. Yeah. The power percentage. Next, if you touch this display, this is called the low voltage control. In the low voltage control, this tab we can able to access. First, in the first line, this is called the power set point, and they will show the current. Generally, this power line we have to set in the always in the percentage, 10%, 20%, 30%, and we have to monitor like what is the sustainable power for our filament. Is it filament only or the material also? Because if you have an organic material, it evaporates at very low temperature. So it's not only the filament, you have also the choice of material that will evaporate.
For the material, we have to go for the automatic process, because yes, but there is some limitation. All material, all filament have the one limitation. Just I wrote some specifications, because they can go the maximum current, the 80 ampere. That time you have to check what the current is following inside your filament. That time we have to maintain and we can observe from the QCM. Then if I start changing in the QCM, then you can understand, yes, the deposition is started from the down. This is called the DC sputtering control. In the DC sputtering control, we can use the DC sputtering control, and we can make the sputtering coating by help of this DC sputter.
Next about the gas line. From the gas, we have to supply the argon gas inside the chamber, and this is the gas control rate, and this SCM, standard cubic per minute, we have to apply the gas inside. Next about there are two tabs generally coming, one coming in the green color, another coming in the red color. Green color is indicate that your process is on, and red color is showing that you are in the off condition, you close this process.
From the gas control, can we use it to vent in the venting process to vent it using nitrogen instead of air? Because if you vent air and moisture, it will take longer time to pump the time. So we have a bottle of nitrogen, and we use the gas control to vent it using nitrogen. Is it possible with nitrogen?
In the first manual, they is given that the argon, nitrogen, oxygen you can use. But when
that's for the sputtering. But for venting the chamber only, not for a sputtering. Just to vent instead of venting it to air.
Then you have to use the nitrogen supply instead of the compressed air. Yes, you can use, like I don't remember, I heard from someone that applying the nitrogen, it will be taking the less time to create the vacuum. I hear that, but to be honest, in the all process, I always use the air supply. Compressed air supply, yes.
Nitrogen is supplied from the air, from the gas inlet, if you want to do nitrogen.
Yeah, from the gas, in the back side, there is one point, you have to apply the nitrogen from there. And nitrogen pressure you have to maintain 80 to 100 psi.
Okay.
Yeah, and one more thing, like the compressed air is not more expensive. Generally, the nitrogen is little expensive because you have to buy the cylinder. That's the people is not using the nitrogen, but you may use the nitrogen. Okay. When you're discussing about the process, there are we categorize in the two parts. One is called the manual process, other is called the automatic process. In the manual process, this manual process only we can control our process by help of a small LCD display. And the next about automatic process. In automatic process, we can control the process by help of the other controller, which we are this SQC310. By help of this SQC310, we have to control our automatic process. Next, how we can, here is the one recipe, how we can do the manual process. For doing the manual process, first important parameter, we have to take our base jar out. Second condition, we have to attach our filament. Third condition, we have to take the base jar down and we have to create the vacuum inside. Then after that, when we reach the vacuum, the near about 10 to the power minus 5 torr, then we can go for the DC evaporation condition. And here is recommended to not use the 50 ampere current during our process. Then we always try to monitor our display that what the current is following. If you are going 50, then we take our power rating down.
We need also to fix the substrate. Yeah?
To
For the process.
if you
No, the substrate, because lift up the jar, touch the filaments, and fix the substrate.
So-
For pumping.
yeah, yes, the fixing in the sub, yeah. First we take the jar up, we fix the substrate, then we have to take the jar back, then create the vacuum inside, then we have to give the power, and we have to monitor what the current is following inside the filament circuit, and we cannot extend maximum 50 amperes. Okay. Then one more important point, in case you did the above process, in case if not happening anything, we are not able to see anything red inside, then what we have to do, we have to check our filament. Second condition, we have to check our materials, like material is pure or not. Third condition, if we are using the more big filament, then also they are giving the more changes in your power. Then the some point we need to check, and this is called the heat and trial method. This depends like which kind of filament we are using and what the improvement step we need to take. Okay. Automation.
Is there a monitor for temperature in the material, not while you are, because some materials may not sublimate at all, not evaporate. So some only the purity. Some material may sublimate not. So to check that, you have to control the temperature. If the temperature is too high, it's not sublimating, which means that this material may not be suitable.
No, temperature we cannot control.
You have to lower the temperature.
Yes, I don't remember anyone.
You see the power, but you still
Yeah, you see that
it's the maximum power,
and then you see it's okay.
And the automatic process, the process is the same here. First, you have to take the lift jar up. We have to attach our substrate. Second, we have to fix our QCM in the proper manner so that suppose this is your substrate and the QCM they are aligned in the same positions. Again, we have to create the vacuum. Vacuum is important in any process. Then we can go the deposition control, and deposition control have some option to control the process. In the next slide, we are going to discuss about the SQC10, how we can operate this deposition controllers. This is your deposition controller. It will look like that. This is called the control. This is called the control knob. You can control your process. You can, by help of this knob, either you can go up, down, left, according to your process, recipe and film. Next, this is called the soft key. Soft key means if you are looking this soft key, the right side there is the mini tab, same like our mobile